This video is all about the Bile Esculin Agar test. We also refer to this media as BEA for Bile Esculin Agar. Now, by knowing what BEA stands for, you'll actually be helping yourself remember why this media is both selective and differential. The B is for bile, which is referring to bile salts. And it turns out that most gram-positive organisms cannot grow in the presence of bile salts. The exception to that are the the group D streptococci. So that includes Enterococcus faecalis and Streptococcus bovis. So for this media, we say that it selects for the group D streps and against the remaining gram-positive organisms, which would be the remaining 6 unknowns for this lab unit. The esculin, the E part of this media, is referring to the differential component because for those organisms that can grow, we can differentiate those that can hydrolyze esculin and those that cannot. So the differential component is based on esculin hydrolysis. And remember, hydrolysis is just the science term for breakdown. In other words, we're trying to see if organisms can break down esculin into glucose and esculetin, which is what you see on this bottom bullet here. Excuse me, I'm sorry. So how can we actually observe these things? Well, whenever we're looking at selective observations, you're looking for growth. If the organism can survive the bile salts in this example, then you will see growth on the media. If the organism cannot survive bile salts, you will not see any growth on the media, and the media will actually look completely unchanged. It will look just like it did before you put any organism on it. The differential observation is going to be based on the formation of a black precipitate. Because I mentioned a second ago, if an organism can break down esculin, it will form glucose and esculetin. Glucose should sound familiar because that is a good starting material for metabolism, and organisms do metabolism to produce ATP, that's cellular energy. But the esculetin here is just a waste product. The bacteria doesn't need it, but we, the science people, can capitalize on it because it turns out esculetin will form a reaction with the iron indicator ferric citrate. And when that reaction happens, a black precipitate forms, okay? So I just really want to clarify this bottom bullet point. We are looking to see if organisms can do this first reaction. Can they hydrolyze esculin into glucose and esculetin? That's the purpose, okay? And in order for an organism to do that, it must have the enzyme esculinase, okay? But we cannot see this reaction happen, right? Because they're all microscopic molecules, but we have found a way to visualize it kind of indirectly. By including ferric citrate into the media, if esculetin is made, then the esculetin will react with that ferric citrate and form a black precipitate on the media, which we can easily observe. So let's take a look at what I mean by this. So on the right here is what the media looks like normally. It's a copper or amber color, and it's a slant. And so to inoculate this media, you just get some bacteria on your loop and you streak starting at the bottom of the slant. You just do like a zigzag streak up. And then you put it in the incubator. And if you pull it out of the incubator and it looks like this tube on the right where you do not observe any growth, then you know you're dealing with a streptococci organism. I'm sorry, a non-group D streptococci, okay? Because remember, I'm talking about this with respect to our unknowns, okay? So really, any other gram-positive organism that is not a group D strep would give this observation and result. They would not be able to handle those bile salts, so they would not be able to grow. However, if you streaked one of our group D streps, not only would you see growth, but you would see this black precipitate because they are both able to survive the bile salts, but they can also both break down esculin into that esculetin, which is going to react with the ferric citrate already in the media and make that black precipitate. All right, y'all, that's the end of this video. Let me know if you have any questions.